वेलकम टू माय यूट्यूब चैनल। एंड आज की जो प्रॉब्लम है दैट इज बेस्ड ऑन ट्री स्ट्रक्चर्स। सो आज की प्रॉब्लम का नाम है सेम ट्री। एंड हम जिस प्रॉब्लम की बात करेंगे उसमें जो भी नोड होगा उसका स्ट्रक्चर इस टाइप का है, यानी हर नोड के पास एक वैल्यू होगी, एक उसके पास लेफ्ट ट्री का रेफरेंस होगा और एक अपने राइट ट्री का रेफरेंस होगा। सो प्रॉब्लम कुछ ऐसे है कि हमारे पास दो ट्री दे रखे हैं और हमें आइडेंटिफाई करना है कि ये दोनों ट्री सेम है नहीं। दैट मीन्स रूट लेफ्ट एंड राइट ये इक्वल है नहीं। इक्वल जब मैं कह रहा हूं तो वैल्यूज की बात करेंगे हम, दैट कि ये इक्वल है नहीं। अगर ये इक्वल है तो ट्रू होगा, अदरवाइज फॉल्स होगा। अब अगर इतना क्लियर है तो हमें इस प्रॉब्लम में करना क्या है वो जान लेते हैं। लेट मी पुट इट दिस वे। ओके, हमारे पास एक फंक्शन है एंड लेट्स से इट्स अ फंक्शन और फंक्शन का नाम है इज सेम और इसके पास जो इनपुट में आएगा दैट इज रूट ऑफ both the trees. Okay, let's call this as A and this is B. So हमारे पास जो आएगा that will be this and this. That means A, which is nothing but a reference to tree node, and we are saying this is the root node. Okay. Similarly B, which is again a reference to tree node, which is root of second tree. Okay, and this function is returning a bool variable, a bool value, true or false basically. Okay, so it is returning a boolean variable. Now this problem can be solved via various methods, but the method I am going to use is recursion. Now what is recursion? I'll talk that in a different video. I'll talk about that in a different video कि recursion होता क्या है और कैसे करना चाहिए, क्या उसकी conditions होती हैं, उसके बारे में एक next video पूरा बना दूंगा proper कि recursion का कैसे implement करना चाहिए। but इसमें मैं recursion use करने वाला हूँ, तो हमारा जो पूरा focus होगा वो recursion के ऊपर होगा। यानी हम इसमें जो तरीका यूज करेंगे वो रिकर्जन यूज करेंगे। एंड रिकर्जन प्रॉब्लम को कितनी काउंट लाइंस में सॉल्व कर देता है, यू कैन सी इन दिस। नाउ व्हाट आई एम सेइंग इज दैट वी हैव ए एंड बी द रूट नोड्स। नाउ इफ रूट नोड इज nil or other one is nil, that means they're not equal, right? So if I can say that if what I'm saying is if A is nil and B is not nil, then that's a false case. If B is nil and A is not nil, that's again a false case. Okay, so that is the first thing we can check. So what I'm saying is if A is equal to nil and B is not equal to nil, in this case we can simply say return false. Correct? We can simply say, right, that if A is not there, B is there, it's not equal at all. Similarly, the other condition, if B is equal to nil, equal to nil and A is not equal to nil, then also we can say return false, right? If this is nil and this is not, or this is nil, this is not, then in both the cases it's a false condition. That's okay. Now if these two conditions are passed, that means they both are not nil. Okay, they both are not nil. We can at least say that part. They both are not nil, or they both are nil, right? Either they both are not nil or they both are nil. Now at the starting we can handle one more condition is wait, let me write this in here. If A is equal to nil and B is not equal to nil, we are saying return false. If B is equal to nil and A is not equal to nil, we are saying return false. Now these are the false conditions. Now if A is equal to nil and B is equal to nil, in this condition we can simply say return true, because they both are nil and they are, so this is a true condition. They both are nil, it's a true condition for us. Now we have handled this scenario. A is nil and B is nil. Now comes the last part. If both are not nil, then we have to check their values. Okay. Now, if I return simply their comparison, A dot val is equal to B dot val, will that work? No, right? Because just values is not sufficient. We still have their left and right. So if you look at the structure, we still have the left and right values to match. But they are tree node again. So if you look at this way, that the left of root again puts us in the same position that we have to solve the same problem again and again. That means we are back to 0. Means if I say 2 and 2 and they are tree node again, we are again at this same position. That's why in the starting I said we're going to use the recursion part, because now and after comparing the values, we'll simply call the same function again, and this time instead of sending the root, I'll say A dot left comma B dot left. Again, and now since I have done the part for left tree node, I need to do the same for the right tree node. I'll say is same for A dot right comma B dot right. And now this function is complete. Now this is same is comparing two trees, A and B. We started with the root node. And with every iteration, I'll not say iteration, with every recursion, we are passing the left and right tree in the comparison, and every recursion call we are reducing the tree level by level, and that's how at the end, at the leaf of this tree, the comparison will end, and the final output will be based on the comparison of left, right, and the value of the root. That's how this is same function is going to work with the help of recursion. I hope I'm able to make you guys understand this problem and this solution. If there is any confusion, any doubt, please mention that in the comment. I'll try to improve myself again, and I'll try to improve the solution. Thank you so much. I'll make a proper video on recursion and I'll update. Till the time, happy learning guys. Like and subscribe. Thank you so much.